Okay, today we're going to be looking at Chapter 5, Topic 9, which is graphing polynomial functions using the zeros, x-intercepts, the roots, all the same thing. They all give you the x-intercepts, which are the solutions for the equation when it's equal to 0. The 0, or the roots of a polynomial, are where the graph crosses or touches the x-axis. They are the x-intercepts. These are the solutions to the equation where it's equal to 0. They can be found by factoring. The factors give you the x-intercepts because they give you the solutions. A 0 that appears an odd number of times will cause the graph to cross the x-axis. However, if that 0 appears an even number of times, it will touch the x-axis and turn around, causing the x-intercept to be a turning point. Factors with an odd number of exponent produce an odd multiplicity, and factors with an even number of exponents produce an even multiplicity. Roots that appear more than once are said to have, like I just said, multiplicity. In order to sketch a polynomial function, we will determine the end behavior based on the degree and the sign of the leading coefficient. We'll factor if it's necessary, because that will give us the x-intercepts, and we'll determine, based on the x-intercepts, whether it touches the x-axis or crosses it, based on the multiplicity of the zeros. And we determine the y-intercept by substituting in 0 for x. All right, let's take a look at this first example. So the degree of this is a third degree polynomial because each factor shows up once and they each have a degree of 1. So it's a third degree. The leading coefficient is positive. So we know that it's going to have end behavior like this. Down on the left side, up on the right side. I'm not going to bother writing out the entire, oh, well, here we go. The left side is going down, the right side is going up. The x-intercepts are the solutions to this when it's set equal to 0, which means that each factor provides an x-intercept based on the 0 of that factor. So the 0 for this factor is -1, for this one -3, and for this one 2. So our x-intercepts are -1, 0, -3, 0, and 2, 0. Plugging in each of these values would cause each factor to be 0, which would cause the entire thing to be 0. The y-intercept can be found by substituting 0 in for x. Okay, so 0 plus 1, 0 plus 3, and 0 minus 2. In other words, 1 times 3 times -2, which is -6. So the y-intercept is 0, -6. So if we look, we have -1, 0, -3, 0, and 2, 0. We also have a y-intercept here at 0, -6. Now we know the end behavior is down here. Okay, so it's going to look something like this. It's going to come up, it's going to pass through here. Remember, it's passing through all of these x-intercepts because they only show up once. Okay, so it's going to pass through here, it's going to pass through here, and it's going to come up like this. Okay, so it looks something like this. And if we go to a graphing calculator, it will look very similar to this. Maybe not exactly like this, but very, very similar. Number 2. Now we'll notice that the degree here, we have this one shows up twice, once, and once, so it's a fourth degree. The leading coefficient is negative because of the negative sign here, which means it's going to go down on both sides, like this. I guess I didn't have to draw all the turns, but yeah, it's going to go down on both sides. It is going to have 3 turning points because it's a fourth degree, so it is going to have turning points, more than one. But the end behavior is going to be like this. It's going to go down on the left side and down on the right side. The x-intercepts are going to come from the solutions to each of these. Okay, so this gives us a solution of 1, this gives us a solution of -1, this gives us a solution of 2, or zeros. These are our zeros. So our x-intercept is 1, 0, -1, 0, and 2, 0. The y-intercept, we would plug in 0, so we have -0 minus 1 squared, 0 plus 1, and 0 minus 2. Okay, so negative 1 squared times 1 times negative 2. So that's negative 1 times 1 times negative 2. So this is positive 2. Because that's negative 1 times 1 times 1 times negative 2. So it's positive 2. So our y-intercept 0, 2. All right. So we've got 1, 0. We've got negative 1, 0. And we've got 2, 0. And we also got a y-intercept at 0, 2. Now, one thing to keep in mind is right here. This factor, this x-intercept, is going to cause multiplicity, which means it shows up an even number of times, which means it's not going to pass through that. It's actually going to be a turning point. It's going to touch it, but not pass through it. Okay, so what it's going to be is it's going to come up like this. It's going to pass through this one, because that one only shows up once. It'll hit our y-intercept. It'll come down and it'll touch this one, and that's actually going to be a turning point, because that's this one right here. It shows up twice, so it's going to be a turning point. It's going to turn around and come back down through here. 1, 2, 3 turning points down on both sides, going through my y-intercept. It looks something like this. Now, these don't have to be perfect. If I graph this, some of this might be a little bit different. It might go up higher than I've shown it going up. The important thing is that the end behavior is correct and these points are correct, and it has the correct number of turning points, the correct number of intercepts, and it should cross or touch it based on the appropriate place. Okay, so number 3. Now, when you have an x out here like this, it's technically x plus 0. Okay, it's technically a factor x plus 0. So the degree here is 1 from here, 3 from here, and 1 from here. So this is a 5th degree. The leading coefficient is positive, which means it's going to have end behavior like this, down on the left side, up on the right side. The x-intercepts, so one of them is here at 0, 3 of them are here at 1, and one of them here at negative 1. So we got 0, 0, 1, 0, and negative 1, 0. Now it is going to pass through all of these because they all show up an odd number of times. Okay, this one shows up once, this one shows up 3 times, and this one shows up once. So it is going to pass through all of these. The y-intercept is actually just going to be 0 because of this x out front. It's 0 times negative, if you plug in 0, you get 0 times negative 1 cubed times 1. But this 0 is just going to turn everything to 0. So the y-intercept is actually just 0, 0, and that's because it's one of our x-intercepts. Okay, so let me put these points. I have 0, 0, I have 1, 0, and I have negative 1, 0. Probably should have made these further away from each other. Might change that. Okay, so it's gonna, the one that it's gonna pass through all of these. So it's gonna pass through here, and pass through here. Now it actually kind of looks like a cubic. It looks like a 3rd degree because of the turning points, and that can happen when you have zeros that show up multiple times. That can happen. And if we look at it in Desmos, you can get a more accurate picture of what it looks like. Now, number 4, you would actually have to factor this before you go about trying to do this, okay? Because you can see that each of these have a negative x that can be factored out. You factor out the negative x squared plus x minus 2. And then we can factor the quadratic x squared plus x minus 2 further. Okay, so in order to graph this, we would need all the factors. So we have negative x, we have x, plus 2 and x minus 1. Okay, so this is a third degree with a negative leading coefficient. Oops. Which means it's going to be up on the left side and down on the right side. The x-intercepts this one, negative x. That's an x-intercept of 0. This one is an x-intercept of negative 2, and this one is an x-intercept of 1. And it passes through all of these because they only show up once. The y-intercept is, of course, 0, 0, because that's an x-intercept, and if you plug in 0, this negative x would make it all 0. So 0, 0, negative 2, 0, 1, 0. Up on the left side, so like this, comes up, passes through, just like this. And it looks something like that. Now, sometimes you might be given a graph and you want to write the factored form of the equation. Well, you need to look at the degree with the lowest degree. So if we look at this one, we know that this has a degree of 4 if it's the lowest because it's got 3 turning points. So it's degree of 4, and it's got a negative leading coefficient because both of these sides go down. Now we know that it touches negative 4 as an x-intercept, and it touches 1 as an x-intercept. So one of the factors, or two of the factors, is going to be x plus 4, and two of the factors are going to be x minus 1. But it is going to have a negative on the outside as well. Now this might be good enough. However, if you substitute, so the only reason that this wouldn't be good enough is because of the y-intercept, which is supposed to be at negative 2. And if you plug 0 into this, you get negative 16, not negative 2. So we're actually going to have to change this leading coefficient into something else so that it will give us negative 2. And if I turn this into 1 over 8, well, now this is being multiplied by 1 over 8, and so is negative 1 over 8. Now it's being multiplied by negative 1 over 8, which, or sorry, 1 over 8. What am I looking at here? Oh, that's 16. Then now it reduces to negative 2. So my factored form is actually going to be negative 1 over 8 as my leading coefficient, x plus 4 to the second power and x minus 1 to the second power. Fourth degree, we have correct x-intercepts. The leading coefficient is negative, but the leading coefficient is 1 over 8 to provide this y-intercept of negative 2 here. So this would be our function, negative 1 over 8, x plus 4 squared, x minus 1 squared. Let's try this one. So this is got 1, 2, 3 turning points. This is a fourth degree as well. The leading coefficient is positive because it goes up on both sides. Now this 0 shows up twice, x minus 2. That factor shows up twice because it touches it. This factor shows up once, x plus 3. And this factor shows up once, x minus 5. Okay, so this would be almost good enough. The only issue is that it probably doesn't have the correct y-intercept at negative 2. So if I plug in 0, so this is almost good enough. I just need to fix it. I need to put the correct number out front so that it has the right y-intercept. Okay, because if I plug in 0, I get, so plugging in 0 gives me negative 2 squared times 3 times negative 5. Which is, so 4 times 3 is 12 times negative 5, which is negative 60. But I need that to be negative 2, which means this needs to be divided by 30. So 1 over 30 needs to go out front. so that eventually it gets multiplied by 1 over 30 and becomes -2 as my y-intercept. Okay, so my factored form of my equation, 1 over 30 x minus times x minus 2 squared times x plus 3 times x minus 5. And that would be my factored form for this function right here, and we can put that in Desmos and check it, and it would be correct.